All right, so let me set up the problem first. We have two particles. We've got particle P that's moving along the y-axis. So think of particle P as going, it does not tell us otherwise, and this is in terms of time, and we cannot have negative time. So we're going to assume that we're in the first quadrant for this problem. So if particle P is moving along the y-axis, we're going to imagine that it's starting from the origin and moving due north, because that is the y-axis. All right. And so that its position at time t is given by y of t equals 4t minus 2/3 for all times t. A second particle Q is moving along the x-axis. So instead of going due north from the origin, it's going along the x-axis from the origin. So you can imagine either the particles are moving toward each other or they are moving away from each other. And that's going to be really important as we solve for the last part of the question. So that its position at time t is given by x of t equals sine pi t over 2 minus t for all times t cannot equal 2. So obviously t cannot equal 2, because if I plug 2 into the denominator of the quotient that represents x of t, I'd get 0. It would be undefined. Well, that immediately causes a problem for this first part of the FRQ, because the first part is asking us to determine, as t approaches 2, what the limit of the position of particle Q is. Well, particle Q is the one that's represented by the quotient. So immediately, you know that when you try to do direct substitution with the limit, that you're going to run into an issue. And this is where the L'Hopital's rule comes into play. All right. So in this particular part, we're trying to find the limit as t approaches 2 of particle Q, and particle Q's function representing its position is sine of pi t all over 2 minus t. Well, remember, when we find a limit, the very first thing that we try is direct substitution. We plug in the value. If it gives us about a value back, that's our limit. If it doesn't, and we run into a problem, then that's where we have to do something else. In this case, when we plug in 2, you're going to get sine of 2 pi all over 2 minus 2. Well, sine of 2 pi is the same as 360 degrees. So it's the same as 0 degrees, either or, puts you in the same place. Remember, sine is your y coordinate. So the y coordinate at 360 degrees is 0. And when I do 2 minus 2, I get 0 as well. Well, that's one of those 2 indeterminate forms that we talked about. So remember, there's actually 7 indeterminate forms there. They're only going to hold you accountable for 2 of them on the exam. The first one being 0 over 0, which is the case we have here. The second one being infinity over infinity, which is not the case we have here. But this is an indeterminate form. Now I'm going to go ahead and write indeterminate form. You don't have to get a point. I'm doing it really for your benefit, so that you remember, okay, if I have an indeterminate form, that is my clue that I have to use L'Hopital's rule. And remember, what L'Hopital's rule does is if and only if you're taking a limit, and when you take the limit, you get either 0 over 0 or infinity over infinity, you are allowed to redefine the limit as the quotient of the derivatives. So right now is the limit as t approaches 2 of sine pi t over 2 minus t. Since we know we've got to use L'Hopital's rule because we got an indeterminate form, we can redefine the limit, and I'm going to put by L'Hopital's rule. And in my opinion, you do need to say something like this. You do need to let the reader know that you are using L'Hopital's rule to answer this question, because one of the points you are getting is the application of L'Hopital's rule. So in my opinion, based on how they're defining the rubric, I would say in your own words or something similar to this, that you are using L'Hopital's rule to redefine the limit. So by L'Hopital's rule, we're going to redefine the limit as t approaches 2 to be the quotient of the derivatives. So we're going to take the derivative of the top and divide it by the derivative of the bottom, and then try plugging back in by direct substitution again. If we get a value, we're good. If we could get an indeterminate form a second time, in which case we would do L'Hopital's rule a second time. Now, when I take the derivative of sine of pi t, that is chain rule. So your outer function is sine, your inner function is pi t. So the derivative of sine is cosine. So it's going to be cosine of pi t. The inner function doesn't change, but then you also have to take the derivative of pi t. The derivative of pi t is pi. So I'm going to put that in the front because it's a constant. All right, and then we're dividing that by the derivative of the bottom. The derivative of 2 minus t is just -1. So really all that does is change the sign of the top. Now you should be able to look at this and see, okay, I shouldn't run into an issue when I try to do direct substitution now, because there's no variable in my denominator. So no matter what I plug in, I'm not going to get 0 unless I were plugging in 0. Well, not even if I were plugging in 0, because there's no variable to make 0. The bottom is going to be -1 no matter what. So really there should be no case where I'm going to get another indeterminate form. So I should be good to go once I'm at this point. So now I can do direct substitution and plug in 2, and you end up getting pi times the cosine of 2 pi all over -1. Well, cosine of 2 pi is the x coordinate of 360 degrees, which is 1. 1 times pi is pi, and then if you divide by -1, that just makes that pi go negative. So your answer is -pi. All right. Now, again, you get 2 points for this problem. You get 1 point for application of L'Hopital's rule. Now, in my opinion, the application of L'Hopital's rule is all of this right here. You need to find the limit as you normally would and show that you get 0 over 0, which is an indeterminate form. And then you need to say something about that you're using L'Hopital's rule and then redefine the limit. So that gets you 1 point right there. So all of that gets you 1 point. Now there's probably ways for you to shorten it a little bit based on how you want to answer it, but you need to show that you get an indeterminate form. Then you need to show that you're using L'Hopital's rule. And then your final point, your second point, is getting -pi as your answer. All right, so that's 2 of your 9 points for this question. Any questions about this part? Now, I can't see the chat window, so y'all will have to speak up just because I'm posting from my iPad. I have a different view than I normally do. So if you have a question, you'll need to speak up. All right, so now the second part says, show that the velocity of particle Q is given by v sub q of t equals, and then they give you this long expression, for all times t cannot be 2. Now, if it ever tells you to show that or verify that or prove that, you're essentially doing what it's telling you to do, and just hopefully at the end of it, you get what they're saying you should get. This is a 3-point problem. If we're solving for v sub q, the velocity of particle q, if you go back to the original question stem, remember both of the functions given were the position functions of the particle. So you've got to remember the relationship between position and velocity. If we're trying to find the velocity of particle q, we're really trying to find the derivative of part of the function that represents particle q, because velocity is derivative of position. So we're going to take the function represented for particle q, which is x of t equals sine pi t over 2 minus t, and we're going to find the derivative of it. Hopefully, if we find the derivative correctly, it's going to give us exactly what it says we should get, and it should look exactly like that. All right, so you're going to get 3 points for this question. You're going to get 1 point for doing the quotient rule, for showing that you did the quotient rule and doing it correctly. 1 point for doing the chain rule correctly. And actually those 2 points are going to come in the same place, because in order to apply the quotient rule correctly, you have to do the chain rule within it. So those 2 points, you're going to see 2 dots right next to each other because you're going to get those 2 points in the same area. And then the final point is for your verification, which is basically just getting exactly what they say that you should get for the velocity of the particle q at time t. All right, so the first thing we're going to do is we're going to find the derivative. I'm just going to rewrite the value or the function for the position of particle q. I'm going to call it x sub q. And that's given by sine of pi t over 2 minus t. Now we want to find the derivative of that, which is the same thing as finding the velocity of particle q at time t. Now, since that is the quotient of 2 functions, we need to use the quotient rule. So just as a reminder, the quotient rule, and by now this should be ingrained in your memory, I hope, is low d high minus high d low all over low squared, where low represents the low function, high represents the high function, the function on the top. All right, so applying the quotient rule, we're going to do low d high first. So the low function is 2 minus t times the derivative of the high function. We already did that. We said that the derivative of sine pi of t was pi cosine of pi of t. So I'm going to put the pi in the front since it's a constant, and then times cosine of pi t minus the high function, which is sine pi of t, times the derivative of the low function. The derivative of 2 minus t is just -1. So all that's really going to do, those 2 negatives are just going to change to a positive, which will give us this part right here. And then it's all over our low squared. So it's all over 2 minus t squared. Now our denominators look like they should. They both have 2 minus t squared. We can get the plus sign of pi t by changing those 2 negatives to a positive. What doesn't look the same is where they're getting this part right here. All right. And it's going to come from distributing the pi and the cosine pi of t. So I'm going to actually do that in 2 steps. I'm not going to do it all at once. So the first thing that I'm going to do is I'm going to take pi and I'm going to distribute it to the 2 and the -t. All right, so oops, let me do that. So when I do that, I get 2 pi minus pi t, and all of that is still getting multiplied by cosine of pi t. And then I'm going to change that second term to plus sine of pi t because of the 2 negatives. And then that's all over 2 minus t squared. Now, the last thing that I need to do to get what they say I should get is I now need to distribute the cosine of pi t to everything in here. Once I distribute that cosine of pi t to the 2 pi and the pi t, I get what they say that I should get for the velocity of the particle q. So doing the distribution, I get 2 pi cosine pi t minus pi t cosine pi t plus sine pi t all over 2 minus t squared. And again, you're getting 2 points, one for quotient rule, one for chain rule. So essentially you're getting 2 points right here, all in one step. Because in order to do the quotient rule correctly, you have to inherently do the chain rule as part of that when you're taking the derivative of the low function or the high function, excuse me. And then your final point comes from showing that your last step is the exact same thing as what it's asking you to show is the velocity of particle q. And that's your 3 points for that question. Any questions on this part? All right, now the last part is the part that takes the most. I actually gave this one 2 slides. It's going to take both slides. And the key here and what makes this one challenging is that you have to understand that it's a related rate question. If you cannot read the question stem and see that, it makes completing this problem very difficult. So it says, find the rate of change of the distance between P and Q at time t equals 1/2. They're not asking for instantaneous rate of change. That would be finding the derivative. They're not asking for average rate of change. That would be finding the slope between 2 points. They're saying find the rate of change of the distance between the 2 particles as they're moving away from each other. So you're looking for how fast or slow something is moving over time. Anytime you are looking to find a value that is changing over time, that is your clue that you have a related rate question on your hands. All right, so we know what the process is for related rates. We did a couple of them, one of which was a bonus. So the process I think you're okay with. It's the thing that makes this one challenging is that your first step is normally to write all your givens. We have no givens in this problem. We're not given any of the distances. We're not given any of the rates. There are no givens, which means before we can even solve for what it's asking us to solve for, we have to find all of those givens. And before we can even solve for anything, we need to know what is the relationship we're even trying to work with here. So that's where that picture that I was mentioning is going to be important, in my opinion. So I'm going to draw, again, we're going to assume that particle P and particle Q, we're in the first quadrant, positive time, positive distance, okay? Particle P is somewhere up here, all right? We don't know where, it's just somewhere up there. We're assuming that we are starting from the origin or going towards the origin. Either one, doesn't matter. All right, particle Q, which is traveling along the x-axis, is somewhere over here. All right, now I'm going to call the distance from the origin to Q, I'm going to call that x of t, because that is how its function is defined. If you go back to the original question stem, it defines its position as x of t. So in the picture, I'm going to do the same thing. The position of particle P is given by y of t, because it's traveling along the y-axis. Now, if you visualize this correctly, hopefully everybody can see that they're moving towards each other or away from each other at a right angle. So what we're really trying to figure out is how fast this distance between them, which I'm going to call z of t, is changing with respect to time. So what we're really trying to find is dz dt. We're trying to find how fast that distance between them changes with respect to time. Now, we've done a couple where we had right triangle relationships, and all of them we use Pythagorean theorem. So we can't really write down our givens. We're not given anything. We don't know x of t at a half. We don't know y of t at a half. We can find it. We will find it, but none of our givens are given yet. So in my opinion, it's easiest to see what relationship you're starting with that relates the position of particle P to particle Q before you start solving for anything. So since I know based on my picture that I've got a right triangle, I know then that I'm going to use the Pythagorean theorem to solve for dz dt. All right, so once I figure out the relationship, then I'm going to take the derivative of both sides, because that's the next part of the process when you have a related rate. And that will show you all the unknowns that you need to solve for. All right, so we know that x of t squared plus y of t squared is equal to z of t squared. That's just the Pythagorean theorem, right? Now, That's the relationship that relates the position of both particles to each other, based on the fact that they're moving in away or towards each other and at a right angle. All right, now, next step is to then take the derivative of both sides. So remember, every variable gets a d something dt when you're doing related rate questions. So when I take the derivative of both sides, I get 2x of t times dx dt plus 2y of t times dy dt equals 2z of t times dz dt. Now remember, the goal was to get something that had dz dt in it because that's what we're trying to find, right? So we're trying to find dz dt, but we don't know x at a half yet. We don't know dx dt at a half yet. We don't know y of t at a half, or dy dt at a half, or z at a half. All of those are unknowns right now. We can't solve for dz dt until we know all of those. So that's what we're going to do first. Now, because we cannot find z until we know x and y, so we can use the Pythagorean theorem, we're going to find x at 1/2 and y at 1/2 first. All right, so that's the first thing we're going to do. All right, so x, I want to use my x at 1/2, which is the position of particle q at 1/2, is going to be found by just plugging in 1/2 into the equation for the position of particle q. All right, we already know the position equation for particle q. Okay. So if you plug in correctly, you get sine of pi over 2. It's sine of pi t, but t is a half. A half times pi is pi over 2. So you get sine of pi over 2 over 2 minus a half. And sine of pi over 2, that's another angle from your unit circle. That's the y coordinate for 90 degrees. The y coordinate for 90 degrees is 1. So you've got 1 over 3/2, which if you do keep change flip or however you remember dividing fractions, this gives you 2/3. So the distance from here to here is 2/3. Now we're going to do the same thing to find y of t using the equation for y of t that was given. So y at 1/2, we're going to take its equation, and if you go back to the question stem, they tell you that y of t is 4t minus 2/3. So that's going to give me 4 times 1/2 minus 2/3, which is just 2 minus 2/3. So you should get 4/3 here. So the distance from here to here is 4/3. Now we have the two lengths we need to solve for z of t, z at a half. We can use the Pythagorean theorem to get that length because we're going to need it as well. We need x of t, we need dx dt, we need y of t, we need dy dt, and we need z of t. We've got 5 unknowns we've got to figure out before we can actually solve for dz dt. We just found 2 of them. We can easily find the third now by doing the Pythagorean theorem. So we're going to solve for z of t, or z of 1/2, by taking the square root of 2/3 squared plus 4/3 squared. So that's just the Pythagorean theorem, because a squared plus b squared equals c squared. So if I want to solve for c, which in this case is the same as z, I'm taking the square root of both of those sides that are squared. All right, if you do that correctly, you should get that distance, z of t, is equal to square root of 20 over 3. So then that makes this distance right here the square root of 20 over 3. So now we've got 3 of the 5 unknowns. The remaining thing that we need to do is figure out x prime at 1/2, because that's dx dt. and y prime at 1/2 because that's dy dt. Once we do that, we've got everything we need to solve for our unknown, which is dz dt. All right, plugging back into the relationship we got by taking the derivative of both sides. So that is the last part. So let's go ahead and get started with that. So we're going to find x prime of t of 1/2 first, which means we need to find the derivative of x of t and then plug in 1/2. Interestingly and easy enough, if you take the derivative of, I'm thinking of y of t. With x of t, we already did it. It's that long equation right there. So I'm going to fill it in, but I expect you to be able to actually do the simplifying part. So I'm not going to do all the baby steps of the simplifying, but I will fill it in. So x prime of t is the same thing as v of q, the velocity of particle q, which we already found that equation for. So now I'm just going to plug in 1/2 for t into that equation. You end up getting 2 pi times cosine of pi over 2 minus pi times 1/2 times cosine of pi over 2 plus sine of pi over 2 all over 2 minus 1/2 all squared. Now, if you simplify, that entire top simplifies down to 1. So if you correctly evaluate that entire numerator, it simplifies down to 1. The bottom simplifies to 3/2 all squared. And you end up getting 4/9 as your x prime, which is the same thing as dx dt. All right, now the last unknown that we need is y prime at 1/2. Now, if we go back to the original function, y is given by 4t minus 2/3. If you take the derivative of 4t minus 2/3, you actually just get a constant. You get 4. There's no matter, so it basically it's the derivative is a horizontal line. So no matter what value of t you plug in, you're going to get 4 for its derivative. So that one was nice and easy. So now we've got all of the unknowns solved for and figured out. At this point, at this point, you're just going to plug into the equation and solve for dz dt. All right, so let me go back to where I was here. So I'm going to rewrite what we were trying to plug into. Excuse me. We know that instead of doing x of t, I'm just going to write it as x for space purposes. 2x dx dt plus 2y dy dt equals 2z dz dt. Now we have all of our unknowns. We know that we said that our x of t was 2/3, so 2 times 2/3. We found dx dt to be 4/9 plus 2 times our y was 4/3 and our dy dt was 4 equals 2 times z, and z was square root of 20 over 3 times dz dt. So now we only have one unknown, which is dz dt. So essentially what you're doing is you're taking all of the left-hand side, simplifying all of that and dividing all of it by 2 root 20 over 3, which is the same thing as multiplying it by 3 over 2 root 20. If you multiply all of that out correctly, you should get that your answer, I think it's 150, yeah, 152 over 9√20. That is dz dt. Now, what you really need to say something about what this means about the context of the problem. Just writing 152 over 9√20 doesn't really tell you much about the distance between the particles. So what you really should be saying, and I'm going to write it sort of at the very bottom, is that the distance or the rate of change of the distance between the particles, you need to say whether they are increasing or decreasing. That distance is increasing or decreasing, and that all has to do with the sign. Since the sign is positive, you would want to say that that distance is increasing. So really, they're moving away from each other. So you would say the rate of change of the distance between the particles is increasing at a rate of, or actually, since I already said rate, I don't want to say rate again. So you would want to say increasing by 152 over 9√20. And that's it. That's your answer. So you get 4 points for this problem. You get 1 point for finding y prime of at a half. So if I go back to my dot system here, that came from right there. You get another point for correctly finding x prime at a half, which is your dx dt. That comes from right here. You get 1 point for correctly writing your related rates equation, which is what you get when you take the derivative of both sides of the Pythagorean theorem, which is this part right here. And then you get 1 point for the correct answer, which is this point right here. Okay. Now notice that you don't get any points for solving for x, y, or z. However, you cannot get the answer unless you do. So there's going to be a lot of questions or a lot of work you do on some of these FRQs where the work that you do you don't get points for it. Not, at least not directly, but you indirectly do because you have to use that information to get your answer, if that makes sense. All right, and that's it. That is number 3. So any questions on this last part? All right, so for the remaining, we've got about 15 minutes left of class. Like I said, the solutions to 5.3 practice and test prep have been posted. You need to compare what you got over the weekend while completing those items. Hopefully you did it. Compare what you got to the solutions. In the next 15 minutes, I can answer any questions you may have if what you got does not jive with what the solutions say you should have gotten. If you don't have questions or you didn't do it, at this point, you're welcome to leave. Just remember, tomorrow you do have something to do for me, even though we're not meeting. It is for a grade. You'll be doing the 5.3 topic questions. So you want to make sure you do that practice and test prep and compare it to the solutions so you're ready to take the topic question assignment, which is a grade. All right. So I'm going to stay live until class time is over, which is 15 minutes from now, actually now 14 minutes. If you don't think you need anything, you can leave, but I will stay here should you have any questions during that time. Okay. If I don't hear from you before then, I will see you guys on Wednesday.
Sorry, there's a question in the chat.
No, so those take a while to grade, so those aren't in there yet. Those bonus that y'all just submitted, those are not all done being graded yet. Tests are going in as I get to them, so some people have their grades in there, some people don't. I'm getting to them as fast as I can, but the problem is because I had to print them all out image by image, I also have to upload them image by image, which is why we're not doing that again. So.
Okay.